This screencast demonstrates how MVX can be set up to work with multiple data source deployment scenarios. The example shown here illustrates how the same visual model and data model can be used with multiple data sources to display current live data from operations, review historical data, and also obtain data from a simulation source, such as an Excel spreadsheet. We're following on from another screencast that demonstrated how an MVX object-based data model can be configured and associated with data from multiple data sources. The program window on the left is a 3D scene that presents a view into a compressor station on a gas pipeline. The window on the right is a configuration program that defines the data that is displayed in the 3D scene, structured using an object-oriented approach. This object-oriented approach to structuring data in an MVX system is also the subject of another screencast that is worth viewing if you haven't already. The first deployment scenario we'll be showing is the display of live data from an operational SCADA system. The example shows a compressor on the left, gas pipes coming in from the upper left through the station via the compressor and then out to the upper right. We're starting out with the compressor running and gas flowing through the station. This scenario is communicating to a separate SCADA software system which is actually running a simulation in this case. We'll close a valve and then see the effect on the station. The valve is closed and you can see that the visual state of the outgoing pipes changed to white to indicate that no gas is flowing at that location. The measured pressure then starts rising. We'll just let this SCADA system simulation proceed until it hits the maximum pressure of 9,000. Once the maximum pressure is reached, some fail-safes kick in and the compressor is stopped and the output valve opened. The 3D scene shows that gas is now flowing through the output valve and the compressor is no longer running. This automatic valve closure scenario is a typical scenario that may need to be reviewed after the fact. We can do this by switching to the historical deployment mode. The data in the scene is now obtained from a process historian and the time of the data displayed can be controlled. The time controls include the ability to go to a specific time and then move back and forward in time as required. We'll first run time backwards to find the point in time at which the output valve was closed. I'm now playing the scene forward in time, observing what happened faster than real time. This functionality can be applied to a host of issue review and training scenarios. Lastly, let's switch to a simulation deployment scenario where no SCADA system is involved. All of the values originate from an Excel spreadsheet. Changes in the spreadsheet are reflected in the 3D scene. We're using an Excel spreadsheet purely as an example of a simulation data source. You can replace it with a more in-depth simulation system as required. Because of the nature of the MVX data architecture, you can mix and match data sources to achieve your operational, analysis, planning and training needs using one visual model and one data model of your system.